All right, so we've split our data into training and test sets. Now let's talk about how do we actually create and train a model on our training data. So recall that R is known as a statistical modeling language, and that just means it was built by statisticians for the purpose of performing statistics, and specifically statistical modeling. As a consequence, R is a rich ecosystem of modeling capabilities, meaning we can implement many different machine learning algorithms, and in fact, we can have multiple ways of doing the same algorithm within R. Okay, so this obviously has its benefits, but also has some downsides. So first of all, let's talk about model specification. So since we have so many different ways of implementing algorithms within R, or there are so many different packages that can provide different algorithms that we can apply within R, what has resulted is there's many different ways to specify the model that we want to create. Right, so we're going to talk about three main ways that you may see in specifying a model. So first of all, we'll talk about what's called the formula interface. All right, so given we have some machine learning algorithm function, right, with the formula interface, we specify the model that we want to create with this kind of a syntax where we provide the response variable, so in this case the sale price, and then tilde. So sale price is a function of, and then we specify the predictor variables of interest. So in this case, we have sale price is a function of neighborhood and year sold, and a few other variables. Now, you will see this very common practice right here, sale price tilde dot. And what this means, this is shorthand for sale price is a function of all the other variables in the data set. Right, so this means it's going to use all columns in our data set except for sale price, and it's going to use all those other columns as predictor variables. You'll see this quite a bit through future lessons in this course, so just realize that's what it's saying. Now another option is you may see where they do these different transformations of the, well, in this case, we do a log transformation of the sale price, the target response variable, and then we may have some other type of transformation of our predictor variables. And this will work. We generally frown upon this approach, and we'll see how we can actually implement what this is actually doing is called feature engineering, and we'll see basically better ways of implementing feature engineering. So this type of an interface where we have this, the response variable, tilde, and then the predictor variables, right? This is called formula, right? Formula interface. And so we're just saying we have some target variable is a function of, and then we list the predictor variables of interest. Now, another way that you'll see is this XY interface. And this is where we actually pull out the predictor variables and we pass them into a variable called, or an argument called X. And then we'll pull out the response variable separately as well and pass them in the function. Right, so we call this the XY interface. And the last one you may see is where we have name specification. And this is where we just provide a vector of the names for our feature variables. We pass that to X, and we pass the name of our response variable to Y, and we pass in the data as well. Right, so these are just three different ways that we can actually specify the model of interest. The one that we will be using most often throughout this course is this formula interface, where we specify the response variable is a function of, and then we specify the predictor variables. All right, now here's the thing. Which one do we use? Well, I just said we're going to use the formula interface quite a bit. But historically, the one that we choose to use all depends on the package that we're going to use to apply some model, right? And like I said, there are many different packages within R to apply different type of algorithms. And in fact, there are multiple packages that we can use to apply the same type of algorithm. For example, discriminant analysis can be performed using the MAS package, the MDA package, or the K-LAR package. The generalized linear models can be implemented with stats package, the GLM package, the GLM2 package, and so on. Random forest could be implemented with the random forest package, the Ranger package, GRF, and so on. Right? So we have many different packages that implement the same type of algorithms. Now, one of the issues that this brings into play is the fact that each package has its own type of syntax for specifying either the models to create them or working with the models to either extract information or make predictions and so on. For example, you can see across all these different packages to implement these different algorithms, if we want to make predictions with the actual model we trained, for each one, we have to actually specify the predict function differently. Right? So here's a challenge that we introduce is by having all these different packages that implement different algorithms, we now have to remember the different syntax used to do very common things, such as predict. So we actually want to make this a little bit easier, right? And we can do that here, and we'll see in just a second, right? So here we see on this slide, if we wanted to just create a simple linear regression model, right? We actually have multiple different ways, but here's two ways that we could do this, right? We could use the LM function from the LM package, or we could use the GLM function from the GLM package, and we could create a linear model, and this actually produces the exact same linear model, but you can see we have slight difference in syntax, right? One requires us to pass this family equals Gaussian, the other one does not, okay? Now, so this just means we have to remember these syntax differences, which typically we don't want to do, right? Simpler, the easier the syntax, the easier it is to build our models, and the faster it is to actually do data science, and that's our objective. So we can actually use what we call a meta engine. Tidy Models is a package that provides a way that we can apply any different algorithm using any different package to implement that algorithm, but we have one common interface to do so. All right. So you'll often see this word engines, right? And that just means, think about it, an engine just being a package to do something. So if we want to implement a linear regression model with the Tidy Models package, we could do so with this syntax down here, which is going to produce the exact same as these two. Now, which one we implement depends on which engine we want to specify. And we'll see how to do that in just a second. But just realize that Tidy Models allows us to have one common interface, one common syntax to remember, but we can implement any algorithm and use any package to implement that algorithm through Tidy Models. All right, so how do we actually build a model with Tidy Models? Well, in the easiest form, we can do this with 3 steps. Create a model object, choose the engine or the underlying package to implement that algorithm, and then fit the model. All right, so what does this look like? Well, first of all, we want to specify the type of model we want to create, right? So this is create the model object of interest. We may want to create a linear regression model, or maybe a logistic regression model, or maybe a decision tree, or a random forest. We're going to learn about many of these different algorithms throughout the rest of this course. But these are just the algorithms that we want to implement, right? So in this case, I just want to create a linear regression model. Now the next step is to set the engine, or to specify which package we want to use to implement that algorithm. So we may want to implement a linear regression model with the LM package, or we may want to use the GLM package or the Keras package to do so, right? There can be many different reasons why we choose a certain engine or package to implement an algorithm. It could be efficiency. It could be more flexibility in the different type of hyperparameters it provides, and so on, right? So just realize that we can, after we specify the type of model, we can now specify which package we want to use to implement that algorithm, right? Now, every one of these model objects will have a default engine. For example, linear regression, by default, we'll use this LM, which means if we didn't include this set engine line here, just by default, linear regression would use the LM package. But we can always change that engine. And then the last step, once we've specified the package to implement the algorithm of interest, is to fit or train our model, right? So here, we're going to create a linear regression model using the LM package, and we're going to fit a model that is sale price is a function of the ground living area, the square footage of the house, plus the year built of the home. All right. And if we want to do a similar thing for the classification model of interest or that attrition data that we're looking at, then in that case, I may want to create a logistic regression model because logistic regression is designed to do classification. And then I'm going to fit attrition, right? The attrition variable is a function of all other variables in our data set. Now, you can see here, I don't set the engine like I did up here. And so by default, logistic regression is going to use the default engine specified, which if you looked at the help function or the help file for that, it should say it's GLM.